All right, welcome to The Explainer. Today, we're popping the hood on C++, one of the absolute titans of programming languages. We're going to get right into it and break down its basic grammar.
Have you ever looked at some software, maybe a game or an app, and just thought, how in the world does it do that? Well, today's your lucky day, because you're about to find out. It all boils down to giving the computer instructions. And that's what we're doing today, starting from a totally blank screen and building a program that can actually think for itself.
And here's the big secret. It's not magic. Not at all. It's just a language. Think about it. English has grammar, right? Nouns, verbs, punctuation. C++ is the exact same way. Once you get the hang of that basic grammar, you can start speaking to the computer. So, let's dive in and learn those essentials.
All right, first things first. Every, and I mean every C++ program, I don't care if it's a tiny calculator or a massive video game, it starts with this exact same foundation. It's like a non-negotiable starting point, and people in the know call it boilerplate code.
So, look at this code. I want you to think of it as the foundation and the wooden frame of a house. You absolutely have to have this before you can put up walls or a roof. That first line, #IOStream, that's like telling the construction crew to bring the toolbox for input and output, things like printing stuff to the screen. Using namespace std, that's just a little shortcut to make our lives easier so we don't have to type as much. And that int main part, that's the front door. It's where everything begins. The return 0 at the end is just you yelling back to the computer, hey, all done, and everything went great.
Yeah, let's zoom in on that int main thing for a second. That's what we call the main function. It is, without a doubt, the most important part of this whole blueprint. It's the front door, it's the on switch, it's the starting line. When you hit run, the computer's first and only question is, where's main? It finds it, and then it just starts following the instructions you put inside those squiggly brackets.
Okay, so our foundation is poured. The frame is up. Now what? Well, now we need building materials, right? In coding, our most basic materials are called variables, and the tools we use to shape them, those are operators.
So, what on earth is a variable? Don't let the fancy name scare you. It's literally just a named box, a container. You give it a name, you put something inside, like a number, a word, whatever, and the computer remembers it for you. It's that simple.
And just like in real life, you've got different kinds of boxes for different kinds of stuff. If you're storing a whole number, like your age, you'd use an int box. If it's a number with a decimal, like a price, you grab a float box. Got a single letter, like a grade on a test, that goes in a char box. And for a simple true or false, a yes or no, you use a bool. Telling the computer what kind of box you're using is super important. It helps it manage its memory and keeps things from getting messy.
Okay, so we have our materials, the variables. Now we need our tools, and those are the operators. These are the symbols that let you actually do stuff with the information in your boxes. They're the hammers, the saws, the screwdrivers of your coding world. They let you add things, compare them, and so much more.
And you already know most of these. Seriously, these are the tools you learned about in first grade. Plus, minus, times, divide, easy stuff. You can do all that math with the numbers you've got stored in your variables. Now, that last one, the little percent sign, that one's cool. It's called modulo, and all it does is give you the remainder after you divide two numbers. Sounds weird, I know, but trust me, it's ridiculously useful. We'll see why in a bit.
All right, this is where things get really interesting. Right now, our program is, it's kind of dumb. It just does one thing after another. To make our code smart, to make it useful, we need to give it a brain. And the way we do that is with something called conditionals. This is the moment our code starts making its own decisions.
Think about a really simple real-world decision. Can you vote? Well, the rule is you have to be 18 or older. So how would a computer figure that out? It's just a yes or no question, right? And we can translate that directly into code.
The way we do it is with an if statement. That's it. This line of code is literally asking the computer a question. Hey, look inside that age box. Is the number in there bigger than or equal to 18? And the computer, it looks, and it gives a simple, straight answer, either true or false.
And depending on that answer, the program goes down one of two paths. It's like a fork in the road. If the answer is true, it does one thing. In this case, it prints, you can vote. But if the answer is false, we can tell it to do something, else. So it runs that other block of code. And hey, see that count command? That's our tool from the toolbox we brought in at the very beginning, just printing text out. This whole if-else idea, this is the absolute heart of making code smart.
Okay, if conditionals give our code a brain, then loops give it superpowers. This is the real power tool on our kit. Loops are all about automation. They save us from doing the same boring, repetitive task over and over and over again. Honestly, this is what computers were born to do.
So what is a loop really? It's just a way to tell the computer, hey, see this chunk of code? Keep doing it. Just keep running it as long as this one specific condition is true. And why does that matter? Because this is the key to unlocking real, powerful automation.
Let's look at one of the most basic kinds, the while loop. It's super straightforward. Before it runs the code inside, it checks a condition. Here, it's asking, is I less than or equal to 5? If the answer is yes, it runs the code. Then it goes back and asks the exact same question again. It keeps doing this until the answer is finally no.
Now, a for loop, this guy does the exact same job, but I think it's a little cleaner, a little more elegant. It bundles the 3 essential parts of a loop all onto one line. You've got the setup, where we start I at 1. You've got the condition, keep going as long as I is 5 or less. And you've got the update, add 1 to I after every single trip through the loop. It's all right there, nice and tidy.
And the amount of work this saves you, it's just mind-blowing. Imagine I asked you to print the numbers from 1 to 5 million. Without a loop, you'd be typing for the rest of your life. But with a loop, it's the same 3 lines of code. That right there is the magic of automation.
Okay, we have our blueprint, we have our materials, the variables, and we have our smart tools, the conditionals and loops. Let's put it all together. Let's build something real, something actually useful. We're going to make a program that can figure out if a number is a prime number.
And just look at this. We are using every single thing we've talked about. First, we need a variable, a box to hold the number the user gives us. Then, we use a loop to check every possible divisor, starting from 2. And inside that loop, what do? We use our special tool, that modulo operator, inside an if statement. We ask, does this number divide evenly, with no remainder? And if it ever does, even once, we flip a little Boolean variable from true to false, basically raising a flag that says, hey, this one's not prime.
And this right here, this is the absolute soul of programming. There's no magic iprime command that we learned, no way. What we did was take really simple, basic tools, our programming grammar, and we combined them in a clever way to build a complex, logical sentence, one that solves a pretty tough problem. That's what coding is. It's problem solving with simple pieces.
So there you have it. You now have the foundational toolkit. You know how to store stuff, how to do math with it, how to make your code make decisions, and how to put repetitive tasks on autopilot. The basic grammar, it's all yours now. So the only real question left is, what are you going to tell the computer to build first? Thanks for joining us on The Explainer.